We have previously created the log parser command that takes a path as an argument. It parses it and prints out a nice summary of its contents. The file I just provided was actually quite small. It only had 390 lines. Next up, I want to try the same command with a bigger file, and this one has 20 million lines. So I'm going to run the same command again with this file, and this time around I'm going to track the memory usage, and I'm going to use a command called time for this. And do notice I'm typing in the full path because this command is different from the time command that my shell bash ships with. And I will pass it in the v flag so it will print the memory usage. If you're on the Mac, I believe it's -L, but for me on Linux, it's -V. So let's see how much memory this is using. This will probably take a minute, but we can have a quick peek in the meantime, and we can see that the memory usage is increasing bit by bit, and this value is actually quite big. Anyway, I will fast forward this and I'll catch you at the end. Okay, so the command has finished. It has printed out all the entries, and you can see it took 42 seconds and it used 5.5 gigabytes of RAM, which is a lot, like quite a lot, especially if we look at the size of the file, which was just 437 megabytes. So clearly we need to do some optimizations in our code. The problem is that we're reading the entire file to memory, and we can easily spot this inside the file reader class. The map method is the culprit, and if this wasn't bad enough, we're actually doing this in two places. It's inside the tokenizer class as well. So how can we avoid this? Well, it's actually not that difficult. The each method I'm calling on the file handle only reads one line at a time in memory. So we just need to avoid passing an array around. And we can do this by evaluating this lazily. And I'm going to add the lazy method here to do so. One other approach would have been to use an enumerator, but lazily is way more convenient in this case. And behind the scenes, it's also returning an enumerator as well. Anyway, I'm also going to add lazy to the tokenizer class. And now let's run the specs to see that we haven't broken anything. Okay, so we do have two failing specs, and it's happening in the files that we just changed. Now, usually these are just assertions that happen on arrays rather than enumerators. So to fix these, I'm just going to typecast our subject from an enumerator to an array. And I'll go to the other file as well. And I'll also typecast this to an array. And now if we run the specs, everything passes. So I'm going to run the same command, the log parser, and see how much memory this is using now. And to have another glimpse at the Ruby process in the meantime, we can see that the memory usage is actually constant, so it's already looking good. Anyway, I will catch you when this command finishes. Okay, so the command has finished. It was about 2 seconds faster, but more importantly, it only used 20 megabytes now, rather than 5.5 gigabytes before. So this is outstanding. So with this performance issue resolved, I wanted to handle something I mentioned at the beginning of this series. I said back then that we're building a log parser that will be easily extendable. And right now there are some issues that prevent this from happening. So for example, say we want to read an Apache log. We'll probably need to open up an existing class and change some definitions there. or maybe we want to read files from a database rather than a file system, the same thing applies. So how can we do all this? The answer is dependency injection. So for example, our current format method returns things in plain text. What if we want them to be JSON or HTML or maybe binary? Well, the way dependency injection works is that rather than having this hard-coded class here, we would read it from an instance variable. So let's say we have another variable here, and this is called formatter. So we would instantiate our parser class with a new argument, and I'll call this formatter. So this will look something like this. Formatter equals this. And probably we would want to use a default, and I'll just paste in the formatter class. So we can instantiate our parser with something like this, parser new, some path, and then here we would have defined in another place our JSON formatter class, for example, and then it would basically output things in JSON when we would call the format method. Now, what if we want to read Apache files? Well, in that case, we would need to override our tokenizer. Though having another argument here wouldn't probably scale very well, so it probably would be better to just read all this from an options hash. So we would need to override these to look something like this. Let's see. So basically for the tokenizer, I'm just going to replace formatter with tokenizer, and inside the tokenize method, I'll just use the new tokenizer instance variable that basically contains the class type we want to use. And what if we want to read things from a database? Well, in that case, obviously we need to replace the file reader. So let's do that. So this should be, what's a good name? Well, reader is a good name. Options reader, and if none was provided, we're going to use the file reader class. And of course here I'm going to use this new reader instance method. Now at this point probably file path is not a good name anymore, so let's replace this. So rather than file path, we're going to use another name, more generic, called input. So this is how dependency injection would look like. And now our class would have the ability to be extended through plugins by other people without necessarily messing around with its internals. And we can see that the specs still pass, nothing has been broken, while leaving the door open to all this new functionality. This was it for this series. I do hope you enjoyed it. If there's anything specific that you want me to cover, please let me know. And in the meantime, I will catch you in the next video.